Hi and welcome. This video is a short video tutorial about how to perform a simple static stress analysis with Ansys Workbench. It can be applied for both student and commercial version, and it can be useful for any Ansys Workbench version starting from 2019 R2. In the description below the video you can find link to the Google Drive where you can find full description of our task. It's a challenge for Ukrainian students that was done by Ansys channel partner Soft Engineering Group. So we use geometry from this competition to show some main steps for creating simulation. We will do some changes with these rulers in reasons that we try to simplify our first analysis. So read this description. It will give you information about what is this and what we need to do. After that you need to download step file with geometry, task.stp, and now you need to run Ansys Workbench. After Workbench running, you will get something like a bench, a desktop, where you draw schematic of your simulation. This is our tools. This is a different analysis system, different type of simulations, and we can drag and drop them and create very interesting and very complex type of simulation with different type of links. For example, project B linked to our project A with engineering data, its material data, geometry and model. But project C linked only with engineering data and geometry. So we can even link different type of analysis with result which was obtained in previous step. And this is our schematic of our simulation, as I say. You don't need to do all this, you don't need to repeat all the steps. You need to repeat it only once. So all things that we need to do during this tutorial is drag and drop our geometry file task.stp into our workbench. It creates object with geometry, and now we need to drag and drop static stress analysis. Here it is, from the panel to our geometry. As you see here, we can see all mouse buttons and keyboard buttons that I pressed for do something. Sorry for my English. Okay, after we link two type of objects, object of geometry and object of static stress analysis, So after we linked to objects with geometry, we need to create all other steps, and we need to double click on model, and we open Ansys mechanical model, where we will create mesh for our analysis, create boundary conditions, force fixations, and so on, and where we will see result of our simulation. You will see something like that. This is our geometry. Here we can see the outline tree of our project. We see different sub-objects like geometry. We have 5 parts, all materials that we use, different coordinate systems, connections, its contacts, and joins, and so on. For first video, we will not change any type of contacts. We will not work with mesh. We will do just a small number of steps. So, when we open our geometry, we need to understand how to navigate them. To rotate them in the view, we need to use middle mouse button. When we click to them and hold, we can rotate our geometry with mouse move. If we hold Ctrl on a keyboard and middle mouse button, we will pan our geometry in a view. If we scroll our middle button, which in most cases also a wheel, so if we scroll this wheel, we will zoom in, zoom out our model. Additionally, it can be repeated with these tools, which we can find here. It can be useful for people who doesn't have additional mouse and use, for example, mouse with 2 buttons, or not a book without mouse. So, additionally, we can change orientation of our model with our triad. If we click on the arrow, we will change orientation of our model. Also, we can click not only on arrow that we see, but also on opposite direction arrow, which we will see if we put mouse over them. So this is our geometry, and we need to create boundary condition. We need to understand that started from Ansys Workbench 2019 R2, Ansys Workbench change interface, and previously we will see here a lot of buttons. Now we see a modern ribbon which look the same to most Windows program. We have 4 tabs which are not changed during our work, and 1 tab which always second, And this tab are context. So if we choose model, we will see tab for model. If we in outline tree select geometry, this context tab will also change tools which we can use. For now, we need to select in our outline tree static structural, and we will see tab where we can find different types of loads, fixation, and so on. First of all, we need to fix this side and this side of our model, but we will do that on different way. For the first fixation, we will select our face, this face, and click Fix It. As we see, it applies our selection of these faces already to this fixation object. If we will click on Fix It when we doesn't have any selected object, if you already have something selected, click on the space near our model. So if we doesn't have any chosen object, any faces, any vertex points, any edges, and we click to fix it, it asks to select our geometry. We can select it by left mouse button, and we also can use Control mouse for select additional object. Also, we can with Control unselect this object. So we need to select only this face and click Apply. Okay, we create additional fixation, but it's not very good because it's not it will not work properly, and we need to change type of this simulation, but we will do it later. So we create fixation, and we need only to create a force. Zoom in to our pin axle and choose both of these faces, cylindrical. After that, we can click on forces, and in difference with fixation, which after selecting geometry show check mark, and that shows that we do everything right. Force have a question mark. Reason why we see question is we doesn't give information about quantity of these forces and its direction. We can change direction showing vector of direction. For that, we need to click here on direction and choose, for example, edges, which will show vector of our force, or we can additionally choose faces and planar faces, and forces will be normal to these planar faces. Additionally, we can change this moment here. We can open and change vector to components. And if we do that, we can apply forces with quantities of forces in different directions. For this task we need only y direction, and we need to create minus, for example, 1000 of newtons. If size of force arrow are very small and you want to see it bigger, we can change the tab to display tab and click to the button rescale. It will change size of our arrow and we will see it much better. Okay, this arrow are placed on point where we click on our surface, but it applied for all surface, for all points and nodes of this surface. So it doesn't matter where we see this mark. Okay, so now we have fixation and forces, and that's enough for creating our analysis, and we can solve. We doesn't have mesh, but when we push the solve button, first it will create mesh for our model, and second it will start our simulation. Our mesh have only 18,000 of nodes and about 10,000 of elements. So it can be this simulation can be solved with Ansys Student Edition, because we have less than 35,000 of nodes and elements. Okay, we have results, but we doesn't see it. For showing some results, we need to select in outline tree solution object, and in solution context tab we will see all type of different results which we can show in our problem. For now, most useful it's total deformation and stress equivalent von Mises. It change check mark to the flash, but we doesn't need to resolve our problem because solution information checked. So we already have results, but we need to read them from the database and push solve button. We don't solve simulation additionally, we only read a result. And here we can see our result. In reasons that I create only 1000 of newtons, we will have very small range of our stresses, 24 megapascals. For example, simple steel, very cheap, will have about 230, 250. So we have about factor of safety about 10. And we can also see total deformation. As you see, it already and always change from the minimum which we see as blue, color to maximum, which we always see as red, for deformation, for stresses, for any results. So we have our results, we can animate them to get a better understanding what we do and how this construction works. Also, we can change scale of deformation, for example, to troop scale, or for 5 outer scale, and this will help to us in analyzing results to understand, does it physical, does it right, does our construction work properly and well, and so on. Now we need to change some type of boundary conditions and forces for more physical results. We will select static structural and right mouse button click, and here we select duplicate. So we create copy of our analysis with all supports, all forces, and so on. Now we can change forces to 35,000 of newtons, and we can delete or suppress second fixed support that's not very physical. For example, we will suppress by right mouse button. Okay, now we need to apply for these faces different type of fixation. We select this face, open here, and select remote displacement. It's apply our selection, but as we see previously for force, we see question mark because we need to add some options for explain how this remote displacement must work. For our case, we need to give degree of freedom in this direction, because here we have geometry additional. Here we have geometry, and here we have geometry, and even here we cut all geometry around our about constructions that we need to solve. This one, it's can be called cantilever beam, something like that. Also, it can be called in different ways. Let's open here and see. I forgot. I'm sorry, I forgot. Bracket. Sorry. This is bracket. So in that direction it can be free, but in x direction and in y direction it must be 0. Additionally, it can rotate around z, but can't rotate about x and y direction. So we add zeros and we can solve additionally. For now it solves, and as you see it's longer than reading results, and we can see a new deformation and a new type of stresses. So what we can say in the end of this video, in the end of this tutorial. First of all, I'm sorry for my English. Second, you will see how to add geometry to project. You see how to apply static structural to our geometry. You see how we can apply different type of boundary conditions and how to simulate our task. Additionally, you learn how to duplicate our result and how our task and how to add different type of results that you need. Additionally, I need to say that if you will add deformation, stress, and any other result when you select something, for example, here, we will not see full geometry, we will see only results on faces, bodies, which we select, sorry. We will see results on selected elements. So if you get something like that, don't shy, don't scream, click on the space and add results that you need. Okay, and now I need to explain why this video are not very good, why it's not edited with program like DaVinci Resolve, Adobe Premiere, and so on. My name is Vasily Vanton, and I have a YouTube channel with more than 400 of videos, with more than 300 of contents, and all this contents about CAD, CAM, CAE and PLM. In most cases about Ansys Workbench, in most cases, but not only. But this channel have a very big problem for wide audience, because I speak them in this channel on my native language, it's Russian. So it can be tricky to understand what I do and what I say. Even if you will use auto-generated auto-generated subtitles. Because it's generate not very good for Russian language, and then auto-translate with Google Translation into English. It's very tricky to understand what do I say. So I write this video without editing, with all phrases and all mistakes that I do when I speak in English. And you can see my real level of English speech skills, and you can think, does it enough for understand? Do you want to see additional tutorial not in Russian but in English? Or maybe it's not so good, so please create video in Russian and don't speak English. So I hope this video can be useful, and I hope my English is not so bad that it can't be understanding, but I know that my English is not very good. So if information can be understanding even with my current English speech skills, and you think information in my channel can be helpful and want to see it in English, please like and share this video. And if this video will reach more than 1000 likes, I will start additional channel where I try to create information in English. So, thank you very much and see you later. Hope.